All right, we're getting into some really good stuff now. We're getting into this big break from what might be called the Aristotelian paradigm, the Aristotelian way of looking at the world that was based on observation and logic. And we're moving towards what might be called the Newtonian paradigm, in which we understand the world through mathematics, and we understand the world through maybe experimentation instead of observation. But we're not quite there. In fact, when we look at the work of Copernicus, we can see him very close to the Newtonian idea, but he can't quite give up the old Aristotelian ideas. So as we all know, Copernicus was the first guy in modern times to say that the Earth was not the middle of the universe with everything moving around it, because that makes sense. When you get up in the morning, you see, oh, the sun is coming up. In the evening, the sun goes down. So from an observational way, it makes sense that that is exactly what happened. But Copernicus said, no, when you look more closely, it only makes sense if the sun is in the middle of the universe and we and everything else are moving around it. So he has this idea that our observations are wrong. But he can't quite explain that in a mathematical way to everybody else. Because even though the math might make sense, it goes against what our observations are and what the logic is of our observations. So here he is in this Aristotelian world, and he's about to break out of it, but not quite yet. And this is what happens. He does all of his work, and he puts together his great magnum opus, and then he's a little bit afraid to actually publish the thing because it's so revolutionary, it's so strange, it's so odd. And so when he finally does publish it, in fact, he died right before the publication came out. When he does publish it, he does so with a little introduction that includes a letter to the Pope. And in this introduction, he explains what's happening. He says, I would like to offer something new. I want to think about something different that, by the way, will change the way we perceive time. But he says, I can't do it just by observation because observation doesn't work that way. Rather, he says, I'm going to look back to the ancients, that third step of Aristotelian science, and I'm going to show you that other people who are really smart before me also thought that the Earth was moving around the sun. And so when he was writing to the Pope, he said, and I'm going to read here, some maintain that the Earth is stationary. That's what most people thought, right? But Philolaus, the Pythagorean, says that it revolves in a circle about the fire like the sun and moon. Heraclides of Pontus and Ecphantus of the Pythagorean make the Earth move on an axis around itself. So right now he's gone back and he's found old Greek philosophers to agree with both of his basic ideas, that the Earth is turning around on itself and that we are moving around the sun. So he says, therefore, having turned over in my mind for a long time this uncertainty of the traditional mathematical methods of calculating the motion of the celestial bodies, I began to grow disgusted that no more consistent scheme of the movements of the mechanism of our universe, set up for our benefit by that best and most law-abiding architect, God, of all things, was agreed upon by the philosophers. In other words, he's saying, look, most people think that the Earth is stationary and we have all of these things moving around us. But the math doesn't work. The math does work if you put the sun in the middle of the universe and everything else moving around it. And now he says he sees that ancient philosophers are agreeing with his mathematical observations and ideas. And so he's saying, look, we can indeed believe, it's okay to believe that the Earth is not standing still, but rather the sun is standing still and we're moving around it. That will have huge and nearly limitless implications later on for Galileo, for Newton, and for us.